Hello, warriors. This is Miss Lemons coming at you with Avogadro's Law. Now, we've actually talked a lot about Avogadro. You might be pretty familiar with his famous number, the mole, 6.02 times 10 to the 23rd power. And that number tells us the number of particles or pieces in 1 mole of substance. So it only makes sense that Avogadro's Law is telling us the relationship between the number of moles and volume. So like I said, Avogadro's law is showing us how the number of moles impacts the volume, or as I like to think of it, how volume is dependent on the number of moles. It is a directly proportional relationship. So if you haven't noticed, everything that we've talked about is directly proportional except Boyle's law. T and P, meaning temperature and pressure, are frozen or they are held constant. And the formula is V1 over N1 is equal to V2 over N2. V1 being the first volume, N1 being the first number of moles, and then the second fraction representing the system after we've changed something. You'll also notice in this picture here that Avogadro's law utilizes a flexible container. And you know that you're going to be working with a flexible container, period, if volume is going to be in the equation, right? Because it's not held constant, therefore volume needs the ability to change. So here we have a piston chamber that is changing volume in response to changing the number of moles. Here's my NASA graph. I'm a really big fan of these graphs. I think they give us a really nice visual. You can see across the bottom that our Bunsen burner is maintaining the same temperature at 300 Kelvin, and that our pressure is being held constant by those two little green weights that are sitting on top of the piston. The things that are changing in this case, you can see that we're using like a syringe here to inject additional particles of gas into this chamber. And because this chamber is flexible or can change its volume and shape, it can actually expand in response to the addition of more particles of gas. Looking at the graph on the right-hand side here, you can see that we do have a linear or a direct proportion here, that as the number of moles increases, or the number of particles, N, the volume also increases. And again, that is because pressure and temperature are being held constant. So let's go ahead and take a look at a few practice problems. These should be on the last page of your lab. Again, they're optional, but I like to walk through a few practice problems so that you guys know what the heck you're doing when it comes to test day. So number 1 says, a sample of hydrogen gas has a volume of 4.2 liters containing 0.33 moles. What would happen to the volume if the number of moles increased to 2.1 moles? Now, I just want you guys to be thinking here. We already know that it's directly proportional. So if volume increases, then the number of moles should also increase. So let's compare our starting value. We've got a volume of 4.2 liters, and then we have 3.33 moles. It's asking us to look for them or figure out the volume if we increased it to 2.1 moles. So before we do any calculations, because we're so well versed in these relationships, we can kind of predict what our volume is going to be. We have 0.33 moles increasing to 2.1 mole, and we know that volume and moles is directly proportional. So if we increase the number of moles, then we should also be increasing the volume. So we know that our final volume should at least be larger than 4.2 liters. I know that I'm going to be using this formula, that's V1 over N1 is equal to V2 over N2, and I'm going to plug in my values accordingly. Once I've done that, I'm going to go ahead and solve for X. The first thing that I want to do is get rid of this fraction. So I'm going to simplify the fraction by dividing the top and bottom. And that gives me 12.7272727272 repeating. So I just made it 7273 is equal to X over 2.1 moles. Now we need to get X out of this fraction, and we're going to do that by multiplying both sides by 2.1 moles to cancel out 2.1 moles. So if I multiply this side by 2.1, I need to multiply 12.7273 also by 2.1. When I do that, I end up getting 26.7273 equal to X. So the nice thing here is that we've essentially solved for x. The last step, as we know, is to round according to the rules of significant figures. If we take a look at all of the digits or the values that have been given to us, this has 2 sig figs, this has 2 sig figs, and this also has 2 sig figs. We want to round our number to have the same number of sig figs as the lowest number of sig figs given to us in the problem, which is 2. So 2 sig figs, I'm going to underline that 2 and the 6. The 7 will round that 6 up to a 7, so our final answer for number 1 should be 27 liters because we're looking for volume. All right, so let's go ahead and take a look at number 2. It says, how many moles are in a sample that originally occupied 500 milliliters with 2.5 moles, and then the volume increased to 750 milliliters. Okay, so before I get started, I know that I'm starting with this equation. V1 over N1 is equal to V2 over N2. And I'm going to go ahead and plug in what I know. It says that it's 500 milliliters with 2.5 moles. So I know that those two are going to be in the same piston chamber, or they're going to be sharing the same fraction. So I'm going to set them up as such. And then it's telling us that the volume is going to increase to 750 milliliters. Now I want to point out 2 things here. One, because we're increasing the volume and we understand that volume and number of moles is directly proportional, we know that an increase in volume also means an increase in the number of moles. So we know that our final answer should be greater than 2.5 moles. The other thing that I want to point out is you might have noticed that we have a different unit here than normal. In the previous question, we used liters. Now, normally in gas laws, we do use liters, but if you are given values in milliliters, you are more than welcome to calculate using milliliters as long as you keep the units the same throughout. So if I gave this value to you in liters and this value to you in milliliters, you would have to convert one or the other so that they had the same unit. But you are welcome to use milliliters if both of those volume units or volume measurements are in milliliters. So that's okay for us to use milliliters as long as it's the same for both volumes. If it's not, you have to convert it. So we are going to use milliliters here, and that's not an issue. The first thing that I want to do to start solving for x is to simplify that problem, or simplify that fraction, dividing 500 by 2.5 moles. That's going to get me 200 equal to 750 milliliters divided by x. Now, we don't like to have x in a fraction ever. The only way we can get x out of that fraction is to multiply both sides by x to get x out of the denominator. So I multiply both sides and I end up with 200x is equal to 750 milliliters. We're almost done. We really only have 2 more steps here. We need to get x by itself, isolate x. So we're going to do that by dividing both sides of this equation by 200. When I do that, I end up getting x equal to 375 moles. Or sorry, 3.75 moles. Sorry, my phone keeps going off. Okay, so the final thing now is we need to round according to the rules of sig figs. This value up here has 1, 2, 3, 4 sig figs. This value has 1, 2, 3 sig figs. And this value only has 1, 2 sig figs. If there was a decimal point here, then we would have 3 sig figs, but there is no decimal point, so we only have 2. Therefore, our final answer should be rounded to 2 significant figures. Underline your top 2 placeholders, round up because this is grade 5 or greater. So your final answer for this should be 3.8 moles. Remember, guys, if you have any questions, you can always reach out to me via Remind, email, or set up a Google Meet with me. And as always, I have 8 a.m. early bird meetings. So if you need to answer a few quick questions in the morning before you get started, or if you'd like me to take a look at your lab before you submit it, you can always pop in at 8 o'clock to get additional help from me. Have a wonderful day, and go Warriors!